Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be talking about 5.1, which is looking at imaginary numbers. Imaginary numbers is sort of a unique topic that's going to stretch out into the rest of Unit 5 for us. It's a little bit confusing, but once you've seen it, it's not too bad. Kind of thinking back to, let's say, elementary school, where when you first talk about subtraction back in first and second grade, you're taught that you can't subtract a bigger number from a smaller number. And by the time you get to, let's say, sixth grade, you learn, well, that's not necessarily true. You can subtract a bigger number from a smaller number, but then you end up with negative numbers. And so in sixth grade, we sort of define what that means and what that looks like. What is a negative number? What does that mean conceptually? So in this topic, we're going to be talking about imaginary numbers, and it's a very similar process. Specifically with imaginary numbers, we're taught from very early on that you can't take the square root of a negative number. And the reason for that is a square root, by definition, has to be the exact number. So, for instance, 4 times 4 is 16, and negative 4 times negative 4 is positive 16. There's no number that I could multiply by itself to yield a negative number, because positive times positive is a positive number, and negative times negative is a positive number. What we're going to do in this section is say, okay, well, let's say you could have a square root that was a negative. What would that look like? And that's what we're going to define as our imaginary numbers here. So, taking just a brief aside here, real quick, our imaginary numbers... Nope. Our imaginary numbers are going to look like this. So we are going to define this value I, for imaginary, as being the square root of negative 1. In defining I to be the square root of negative 1, we're allowing ourselves to define any of these situations. So, for instance, if I have square root of, let's say, negative 25, square root of negative 25 up till now is something that I wouldn't be able to take the square root of. But now what I'm doing is I'm going to separate it into the square root of 25, which I know the square root of, and the square root of negative 1. The square root of 25, as before, is plus or minus 5. And now we're defining the square root of negative 1 as I. So the square root of 25, negative, would be plus or minus 5i. So that's pretty much what you have to do for 60% of this assignment. So if I have any of these square roots, negative 36, for instance, right? Yes, up until now we didn't know the square root of negative 36, but we know the square root of 36. And we know the square root now of negative 1. We're defining that as the imaginary number I. So plus or minus 6i. And to do one more, square root of negative 121 is the square root of 121 times the square root of negative 1. Square root of 121 is 11, and the square root of negative 1 is I. So that's it. I could also give you some questions that don't have a perfect square as the radical. So for instance, let's say square root of, let's say 48i, or sorry, 48, negative 48 rather. So if I actually take square root of negative 48, yes, you can separate this into square root of 48 times the square root of negative 1. Square root of negative 1 is I. The square root of 48 you would have to simplify, and if you need a review, that would be back in your Unit 0 assignments of how to simplify a radical. But the square root of 48 simplifies into square root of 16 times the square root of 3, and the square root of 16 is plus or minus 4. So simplified, that would be plus or minus 4 radical 3i. To do one more here, if I ask you the square root of negative 125. That can be separated into the square root of 125 times the square root of negative 1. Square root of negative 1 is I. Square root of 125 can be broken into the square root of 25 times the square root of 5. And so simplified, this would be plus or minus 5 radical 5i. So that's the majority of your assignment. just introducing this concept of imaginary numbers and being able to separate the power. Another thing you'll be asked to do in Unit 5 is to be able to simplify expressions involving imaginary numbers and also to potentially multiply a complex expression involving imaginary numbers by what's known as the conjugate. So let's look at first, what does simplifying these powers mean? Well, by definition, we said I is equal to the square root of negative 1. So if we're talking about an equation in terms of I, just algebraically, let's say I squared both sides of this. Well, that would mean that I squared then would be equal to the square root of negative 1 squared, which would be just negative 1. And if I took I to the third power, I could break that up by the definition here as being the negative 1 times the square root of negative 1 by plugging in I and I squared. And that would be like writing negative I. And then I to the fourth power would be negative 1 squared, which would be a positive 1. Okay. So based on these four definitions, I should be able to simplify any term involving I. So for instance, let's say I asked you to simplify I to the seventh power. What you're going to do here is look at which one of these terms, if I divide out a factor of 4, what am I left with? So for instance, I to the seventh power, if I divide out an I to the fourth power, which would just be 1, and you could write this step if you need to, but not necessary. If I write out I to the 4 times I cubed using properties of exponents, I to the fourth power is just 1, which means I to the seventh is the same as I cubed, which simplified then would be negative I. For your assignment, if you're just going from here to here, that's acceptable. Let's see another one. I to the, let's say, 16th power. I can divide out I to the fourth power, so I to the 4 times I to the 4, and you can use your product rule or your power of a power rule, but I to the fourth power is just 1, so that means I to the 16th simplifies to 1. Number 8, I to the 21st power. 4 goes into 20 evenly, which would leave me with I to the first power. And by definition here, I to the first power is square root of negative 1. So for all of these types of problems, you're going to end up with one of 4 answers. You're either going to have the square root of negative 1, negative 1, negative I, or just 1. The other thing that's leading into the segue for the rest of Unit 5 is you're asked to identify what is the conjugate of an expression. So in later sections in Unit 5, we're going to be adding and subtracting these complex numbers that have both real and imaginary parts. So the easiest way to think of a conjugate is really the same but opposite signs. So for instance, let's say I had 5 plus 2i, and I asked you for the conjugate. It's going to be the same binomial, but instead of addition, you would have subtraction. And similarly, if you have, let's say, subtraction, then the opposite would be, for that imaginary part, addition. And this is going to be the same if you have a complex number such as radical 3 plus radical 3 plus 2 radical 5i. The conjugate is the same terms for the binomial, but we're going to switch that sign. That's it, guys. I know it's really brief, but hopefully this assignment is pretty quick. We'll get into the more complex stuff here later in Unit 5. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon.